So let's talk about heat and temperature as well. Um, when you touch an iron, your hand gets super hot and you can even burn yourself, right? And so basically, um, heat is transferring from the iron to your hand. And the thing to remember is that heat travels from the more hot object to the less hot object. So if I were to touch your hand right now and your hand was really cold, you you would be touching my warm hand and your hand would start to feel warm as well. That's because the heat from my hand is traveling to your hand and making your hand hotter. Temperature is a measurement of how hot it is. Um, Lower temperatures are cooler, higher temperatures are hotter. And then also the particles in an object. Temperature also measures how fast they're moving. If they're moving super, super fast, like in gases, that means the temperature is really, really high. And that's why there's water vapor at high temperatures versus ice, which is packed together and the particles barely move at low temperatures. And there are actually four laws of thermodynamics, and it starts with the zeroth law. So this law is basically, it can be described as, so the definition is when two systems have equal heat flow and one of the two has an equal heat flow to a third system, all three systems have an equal heat flow. So basically, it's saying something along the lines of if x equals y and y equals z, then x equals z. Or, in simpler terms, if 1 plus 3 is equal to 3 plus 1, and 3 plus 1 is equal to 2 plus 2, then 1 plus 3 is equal to 2 plus 2. That's essentially all it's saying. It's a super simple law. The first law says energy cannot be created or destroyed, only changed in forms and transferred, which is what I stated earlier with the potential energy to kinetic energy. The potential energy is going to convert into kinetic energy when the object is in movement. And then once the object stops, that kinetic energy has transformed into potential energy. The second law is that when two systems are touching, heat will flow from hot to cold until both systems are at equal temperatures, which is basically what I had stated earlier. I'm shaking your hand, and for me, your hand is super cold. So you're experiencing my warm hand, and the heat from my hand is traveling to your hand and making your hand warmer. And if we keep shaking for a super long time, eventually both of our hands are going to be the same temperature. And I won't think your hand is cold anymore, and you won't think my hand is hot anymore. And then the third law, or technically the fourth law, since there are four laws, is that 0 Kelvin means no kinetic energy. So here in America, we use the Fahrenheit system, which is depicted in this picture right here. We use this system. Most of the rest of the world uses Celsius. It's basically two different scales for measuring heat or particle movement, as we explained earlier. Kelvin is basically the temperature in Celsius plus 273.15. So let's say your house is around 72 degrees Fahrenheit. Converting that to Celsius gives us around 22 degrees Celsius. So in Kelvin, Kelvin would be 22 plus 273.15. It's basically 295.15 Kelvin. And the third law of thermodynamics states that at 0 Kelvin, the particles have no kinetic energy. They are completely still and they aren't moving at all. And yeah, there are some more things surrounding that, and I would suggest looking into 0 Kelvin and can particles of an object actually ever stay still. It's super interesting. If you're interested, I recommend looking into it. This example is going to depict our second law. If you have a hot coffee, and it's 82 degrees Celsius, 82 degrees Celsius is 179.6 in Fahrenheit. And the room is 20 degrees Celsius, which is 68 degrees Fahrenheit. Then eventually the coffee is going to cool down and the air molecules in the room are going to heat up until they're the same temperature. So let's talk about hot air rising. When I was in 9th grade, I read To Kill a Mockingbird. And there was this one scene in the book that basically all the white people were on the first floor and all the black people were on the second floor. And the reason they were placed on the second floor was because hot air rises and the white people wanted to be cooled while basically warming up the black people. And it worked because hot air rises. So let's go back to density. Density is mass divided by volume. Mass is the amount of stuff there is in an object, and volume is the amount of space. And we talked about energy. When particles in an object are moving super, super, super fast, they have more energy. And they are also have a high temperature. So more energy means there's a higher kinetic energy because the particles are moving so fast. They're going to have a high kinetic energy, leads to them expanding. And basically, you're going to have molecules that are moving out in space and taking up more space. And so this equates to less molecules in more space. And that's where density comes in. So if we remember that formula earlier, mass divided by volume is density. So if your mass stays the same, but your volume if your mass stays the same, but your volume increases, your density is going to decrease. And as your density decreases, you're going to layer on top of high density things. Hot air is less dense than cold air. So it's going to layer on top of cold air. And this is why it rises. But it's also a cycle. If you see this note down here, as hot air rises, its temperature decreases. So you have air here and it's being warmed up. And so it's going to the top. But then as it increases in altitude, it's getting colder and colder. So it's going to drop back down. And it's going to be a cycle where it warms up again and rises, then cools and goes down in altitude, and then over and over and over again. And then this video is going to summarize how hot air balloons work.
Ever seen one? Have you ever wondered how a hot air balloon works? How does it get up there? And how does it stay up there? Well, it's all about the air. There's nothing special inside the balloon that makes it float. It's just the same air that we're breathing right now. So how does that keep the balloon up there? Well, even though you can't see it, air isn't nothing. It's something. Air is made of matter. Anything that you can touch or feel or that takes up space is made of matter. So air is made of matter, just like water is made of matter. And so are the clothes you're wearing and the food you eat. Even your body is made of matter. So what kind of stuff is matter made of? It's made of tiny things called molecules that are way too small to see, but they're there. So both inside and outside the balloon, there are many molecules of air moving around and taking up space. But you know what's fun about molecules? When they heat up, they start to move differently. That's right. When something gets warm, the molecules that it's made of start to move around faster, bouncing around and spreading out. And that's the important part. They spread out. So let's think about how that would happen in a hot air balloon. When the balloon is on the ground and ready to go, it has some air inside it. And that air is the same temperature as the air outside of the balloon. So the air molecules are all moving around at the same speed and are just as far apart from each other, both inside and outside of the balloon. But then the balloon pilot makes the air inside the hot air balloon hot. You see, these balloons don't have engines like airplanes do. They have big heaters that send flames up into the balloon. So when the pilot turns on the flames, it heats up the air inside it. That makes the molecules of air start bouncing around inside, and they start to get further and further apart from each other. As these molecules spread out, they start to fill up the balloon even more. And when those molecules of air inside the balloon start to take up more space, we say that the air becomes less dense. Soon, the air inside the balloon becomes less dense than the air outside. Now, maybe you remember when we talked about why some things float and other things sink. We learned that things that are less dense than water will float to the top, while things that are more dense will sink. And the same is true with our balloon. The hot air inside the balloon is less dense than the cool air outside, so the balloon can float up. In fact, warm air always floats up. Have you ever noticed that in the winter, when you have the heater on, the downstairs of your house is usually a lot cooler than the upstairs? That's because the warm air in your house is rising to the top. So in a hot air balloon, the hot, less dense air inside the balloon rises up on top of the cooler, denser air outside, and that makes the balloon rise. Now, how does the balloon get back down? Well, the pilot opens a flap at the top of the balloon that lets the hot air out. As the balloon fills with cooler, denser air, it begins to sink gently back down to the ground. It may be hard to believe that something so big can be carried by little molecules we can't even see.
That summarizes how hot air balloons work. Basically, you'll have the less dense air rising above and lifting the balloon. And if you want the hot air balloon to come back down, you just take off that flap above, like she was talking about, and have the more dense air come down. Thank you so much for watching. And now, next time you want to go on a hot air balloon, you'll know how it works.